In this section, we're still going to focus on probability, but now we're going to focus on the idea of the addition rules for probability. Keep in mind things we talked about before. To get the probability, you're simply looking at the number of successes divided by your total number of outcomes. What we've looked at so far is, what if there's one outcome that we're looking for? For example, the probability of rolling a 1, the probability of flipping a head, the probability of a family with 2 children having 1 boy and 1 girl. But now when we look at this, now we're going to look at the idea that multiple events could actually make something true. Well, let's focus first on the idea of mutually exclusive. And what does mutually exclusive mean? Mutually exclusive is simply this: 2 or more events that cannot occur at the same time. So now we're simply focusing on 2 events that can't occur at the same time. For example, you can't be tall and short. You can't have a temperature that's over 87 degrees and under 53 degrees. When it comes to that idea of mutually exclusive, we're going to have 2 different rules of addition. The first rule, and we'll talk about this addition rule, we're talking about the probability of A or the probability of B. All you're simply going to do is add the probability of A occurring and the probability of B occurring. This would be your formula if you have mutually exclusive events. If you have what we call mutually non-exclusive events, we're still talking about A or B, and the formula looks very, very similar. Probability of A plus the probability of B. The only difference here is we have to take out that overlap, and I'll explain why in 1 minute. So we have a different formula. The top formula is when we have exclusive events, events that can't occur at the same time, and non-exclusive events, when things can occur at the same time, and this would be when they occur simultaneously. Let's look at an example. So in our first example, we're looking at the probability that someone's over 6 foot tall, probability someone's under 5 foot tall, and we have the numbers written there. So what if we're looking for the probability that someone is over 6 foot tall or under 5 foot tall? Well, in this case, these events cannot happen. You can't be over 6 foot and under 5 foot tall. So these would be mutually exclusive events. So in this situation, to find this probability, I would simply just add the 2 probabilities together, the 0.23 and the 0.19, and my answer is simply going to be 0.42. I don't have to worry about an overlap, so I don't have to worry about any number being double counted. Down here, I have mutually non-exclusive events because it can rain and be cold outside. So if I want to find out the probability that it's raining or that it's cold out, well, not only do I have to take the 0.56 and add the 0.73, but here's the thing. This has been included here, and it's been included here. So I have to subtract off that 0.41. When I do that, I'm going to end up with a probability of 0.88. If I look at this using a Venn diagram, basically here's what I'm seeing. Days that it rains, days that it's cold. Well, this 0.41 represents this section in here when both items are true. Notice that it's being counted in the rain circle and it's being counted in the cold circle. So when I add those 2 together, this number is being double counted. That is why I subtract it off.